Hello, welcome to our room. Welcome to my presentation. My name is Christophe Devey, and I'm going to tell you today about heat transformation and more exactly how we believe it's important and why we believe it's important for the world, for the challenges we are facing now. Let us start. I will show you some slides. I will try to see and go through this to understand a bit more about it. Here's the presentation. And let's go now. So heat transformation, I chose a title which is pretty broad, and actually we are going to talk about what it is. But first, what we want to achieve is on this picture. We want an environment, we want a beautiful place where we can live, where we can enjoy living. And for this, we are talking about good health, clean and affordable energy, sustainable communities, of course, and climate action. And this is very important. Of course, I'm not working alone. I listed here some of my co-workers, and we are doing some very good job, and I really enjoy working with them. And that's important. We don't do things alone, but we can do a lot together. Let's get started. And I'll say, if we take one picture, this is Klaus and me on the picture, we are looking around and we do see basically the problem. Here it's visible. It's not always visible actually, but here it is very clear. This is not what we want. This was taken in the middle of Stockholm. Imagine how it is elsewhere. We don't want to see that again. And it tells us a lot about what are the challenges actually. But if we try to dig a bit into these challenges, why they are so important? Well, first, climate change. We know that we have to do a lot to get below the 1.5 temperature increase worldwide. It should be rapid. We don't have time to wait. And yes, it's a very significant transition. It goes for the way we live on land, the way we produce energy, the way we build industry, cities, housing, transport. And basically, if we want to set numbers on this, what should we reach? What are the goals? Well, we should basically halve our CO2 emissions within 20 years. That's a lot. But also we should get to zero by 2050. It might sound that 2050 is very far away, but it's not. Think about as much as we have to do. What is more important that now, basically, we have one decade to start doing this, to start good, to get the knowledge that we can reach this. Time seems pretty long on a lifetime, but it's not when we think about technology development. Let's try to think about this. A second challenge, which is somehow coupled to that, but rephrased often a bit differently, is basically clean air. We think it's basically clean. We don't see pollution in air, but we know that actually in Europe and the US, adults, children, men, women, everybody smokes about 1 cigarette a day because we live in cities. That's a lot. I wouldn't let my children smoke cigarettes, but they do so by living in city. Let's think about this. In Asia, of course, it's much more worse. And in some Chinese city or Indian city, we're talking about 60 cigarettes a day, the worst days. That's enormous. We need to do also something about this. Let's boil it down. Because as I said today before, it's something what we call invisible killer. Because we don't see it, but it's still there. CO2 also is invisible. And this is a lot about what we are talking about here. It's not visible, but we have to create some solutions directly. Before that, of course, we have to make it visible also, so we know what to address, we know how to follow it. But this is very important. These are invisible problems, and we should try to address them. Okay, so what do we need to do? Reduce fossil fuel. We have all heard about that. For clean energy, fossil fuels are no good. They should be banned. We should get rid of them. We should improve efficiency. This ship, like we see on the background picture, well, you have still hot gases going out. It's energy which is lost, fuel which is burned, just to go in the atmosphere. This cannot continue like this. We should capture CO2. We cannot just release it, either prior or after. And we should also capture pollutants, make sure that they don't end up somewhere, and not somewhere that it contaminates us or our planet. And I think we are going to talk about the two which are underlined. I will go briefly about it. We also work with the other ones, but I won't have time today to talk about it. So firstly, about how do we get heat? Well, we have to think about a process where we have heat transfer, and that's pretty well known. Industry has been working with heat transfer for a very long time. We know how to build the heat exchangers, but how to optimize them, how to get them, was not so important because energy was so cheap. So yes, we get what we need, and there are some losses, we can live with it. That's not working anymore. And how do we go? We could try trial and error, try to modify existing technology, but that's not ambitious enough. We should try to be able to see inside how to make them better, to learn from inside, to get the knowledge to make them better. And we do that by having heat transfer, by trying to invent, to do simulations, to see inside the problem and to invent solutions. Very important to be able to see what is inside and to automatize the process. Very complicated processes, very difficult to get this in our mind, but computers here are helping us. And this is what we are working with. Now, briefly, and to a second part, was talking a lot about clean air. Let's try to do something about it. And this is what we want to do. And I'll take the example of the ship. Can be other type of system, but I think ships are today probably the worst example worldwide, and they're everywhere. So let's take this as an example and see how we can go and how our research can help here. If we talk about standards today, the Maritime Organization said, okay, sulfur fuel is very bad. We have SOx, a lot of sulfur oxides emissions. We should cut them down. Everybody agrees on that. It should be done. It was done for land-based power plant a long time ago. And they say from 2020, no more this. So you have two ways. You can use low sulfur fuel, or you can capture the fuel. Very often, the cheapest is to capture the sulfur outside. And this is what you are here. You have polluted gas coming down here, and they go up to clean exhaust. And that works pretty well. What happened with the sulfur? Well, we take in seawater. It's coming here, wash it in this scrubber, and then we go down, separate this, and we have the water here. What happens to this water? Well, according to the regulation today, you can do whatever we want with it. Don't need to pay to get it disposed in a safe manner. Just throw it back to sea. Wait. We have sulfur, we have pollution here. It's gone, but it ends up here instead. So instead of polluting the air, they're polluting the sea. We can see that's not going to work. That's not sustainable. We need to find better, and we need also better regulations. And this is what we are working with. But before how to find a solution, we need to understand what is happening. In particular, when we are talking about pollution, we have gases, we have a lot of chemistry going on, and we have some molecules, could be harmful matter. They form nuclei, they form particles. Sometimes they don't. And these particles grow. And we see that when we talk about meter size, this side of the scale, that's basically on the ship level, the fumes going out. And then we start from nanometer size, where we have the molecules. And we have a transfer between all this. And this is what we research. That's what we try to get the tools to be able to model it, to understand what is happening. And something that we notice is happening in the atmosphere is basically that some compounds, sulfur oxides, for instance, form acids, and these acids form particles later. These particles are very harmful. We don't want this to happen in the atmosphere. But one idea would be, what if this happens on ship and we can trap these particles? And we would have cleaned the gas. And this is basically what we try here. That's our process. We try to capture them and to form this particle in this phase here, for much before they reach the atmosphere. So we can capture and trap them on ship. That would be good. Also, these particles are ammonium sulfate, ammonium nitrates. That's pretty nice, actually, because we can sell them as fertilizer. So they would be disposed of. It won't even cost anything. So we have a zero waste process here. How to do that? Well, there are a few things we need to understand before we can make it to work. We try to understand the mixing, the chemical reaction, how fast we can build this particle, which means how fast we can remove the pollutants. But we are going forward with that, and we are doing very interesting research. Try to explain a bit what is happening, and here is a movie. I will start it in 2 seconds. Yes, it's coming, and what we are looking here is oxidation, how we form basically the acid from the sulfur oxide. And we inject the ozone on the left here. It's going to react to form N2O5, which is the first step toward nitric acid. And we can see how it is. This is a mixing problem. We have to understand how it mixes, and we want to go this forward. just a small taste. If you want to know more about this, I'm happy to talk to you later, and you can see also our publications. So this was a very short talk, small introduction to what we do. But I thank you anyway for your attention, and I want to finish on a maybe optimistic scale. Here is a picture during lockdown in India, and for the first time in 30 years, inhabitants of the city could see Himalaya. It's a massive mountain, it has always been there. There was so much pollution, they couldn't see it. But as soon as there was lockdown and they couldn't travel anymore, couldn't use the car, industry was partly closed down, then suddenly it became clear sky. Doesn't mean the air was very clean, but much cleaner than before. And for the first time, they could see the effect of pollution. So yes, clean energy is possible. This is an optimistic example, but for that, we need strong will and decision, and also we need the right knowledge. And this is what we work with, and we hope for the best. Thank you so much.